G'day chemistry students. In this video, we are looking at dot point 6.1.1, doing a little bit of revision with some of our naming rules, looking at inorganic acids and bases. Let's get into it. First off, I have a bit of a flowchart here that we can use to name inorganic acids. When we're looking at naming acids, what I want to identify first is that technically, when we're looking at inorganic acids, we should be following the naming rules that we learned about all the way back in year 12. So for example, this guy here, H2SO4, should be formally known as dihydrogen sulfate. However, we have a lot of Bronsted-Lowry acids. They have general formula HA. They are able to dissociate in aqueous conditions. All of our basic, fundamental, common acids have this other common name, and they're common enough and used well enough and have their own naming system to the point where IUPAC generally accept that name as well. So you find that a lot of these acids have two names, a really formal name that doesn't get used very often, or a common name, which for this one would be sulfuric acid. So we can follow a little bit of a flowchart. If we do know that we have an acid that doesn't follow the general formula HA, we can just use our molecular rules that we've used before. So name each of the elements or the polyatomic ions, indicate the number of them using mono, di, tri, tetra prefixes. If it's an acid that has a general formula NHA, we first have to determine whether or not the anion is monoatomic or polyatomic. So we're looking at whether it's, say, a chlorine or a fluorine or a bromine, that would be monoatomic, or polyatomic, something like a nitrate or a sulfate or a phosphate. We then have a bunch of naming rules that come afterwards to tell you what kind of suffixes you need to use. So for example, we could have hydrofluoric, hydrochloric, hydrobromic acid for things that are monoatomic. For things that are polyatomic, what you're going to find in this course is that you're going to be using this ic suffix a lot, not really using us a lot. This depends on whether or not the polyatomic ion is an 8 or an ite. Generally, for acids, we're using 8s. Nitrates, sulfates, carbonates, etc. So in any of those situations, we'd be using ic at the instead of 8 when we're talking about the polyatomic ion. So for example, nitric acid, for a carbonate, it would be carbonic acid. For a sulfate, it would be sulfuric acid that we would be using. When we're looking at naming bases, we just generally use the appropriate naming rules. They don't have the same sets of common names or that second naming system. So for example, if we have a hydroxide, we just call it the metal ion hydroxide. If it's an oxide, we call it the metal ion oxide. There are some molecular bases. So for molecular substances, we just need to name the molecule by identifying each element in order and then using prefixes to indicate the number of each element that is present. So for example, NH3 would be nitrogen trihydride. This is probably one of the ones where ammonia is a really common term, and I guess would be an exception to the rule of we just use our naming rules. But for other molecular substances, you may just be using the really formal naming system like we've got there. We also have organic acids and bases. We haven't looked at organic substances in any detail really yet at all. That will be taught specifically in Module 7. We're going to be using organic naming rules, which will be taught at the beginning of Module 7. They also have lots of common names as well, but we'll talk about them in context when we hit Module 7. What I want to look at now are some common acids and bases. For most of these substances, we probably want to be identifying these by formula, not even really thinking about naming rules or anything like that. But here is a list of a bunch of acids and bases. In particular, I want to identify vinegar or ethanoic acid. This is an organic acid. As I said before, we're not going to be using much of them really at all in this acids and base topic. Certainly won't be using naming rules to identify them, but vinegar is something, or ethanoic acid is something that you will see, and you will see a formula similar to one of these. Citric acid may come up as well. This is a really complicated way of naming it. We'll probably be using the common name. This is its formula over here. For the organic bases, the methanamine and the propanone probably not going to be coming up too much. We certainly spend a lot more time in this topic looking at acids rather than bases, But yeah, for our bases, we've got hydroxides, carbonates, oxides, ammonia will be our other non-ionic base that we might be talking about a fair amount. Otherwise, you've got these guys here, which are our common acids. Thank you very much. In the next video, we're going to start unpacking different kinds of reactions that involve acids and or bases. But until then, have a good one.